This is section 131. We're going to take a look at the introduction to functions. Yay! So we're going to determine if a relation is a function and determine if a graph represents a function. So one of the concepts in previous math classes is the function. There are many ways to define a function, and we will begin by defining a function as a special kind of relation. So our definition: a relation in which each x-coordinate is matched with only one y-coordinate. So meaning the x-coordinate can't repeat with multiple y-coordinates, is said to describe y as a function of x. And this is the special math language that we say. So a function is essentially a special type of relation. That's all we need to know. Special type of relation where x is matched with only one y-coordinate. So let's kind of take a look at what that means like visually. How do we determine that? So if we look at this example here, if we're just looking at numbers, it says each input, the x value, must be matched with only one y value. Well, in this instance, -1 is matched to both 0 and 5. So therefore, because it has two different outputs, we're going to say that it's not a function. Let's look at another example. If I just have these 2 points, or these 3 points here, well, 2 is matched to 5 and 2 is matched to 7. Again, this is not a function because my one x value, 2, is matched to two different y values. Let's look at a few others. This time we have 4 points. So -2, no, 1 is matched to 3 and 1 is matched to 4. So this is not a function. And then on the next one, -2, no repeat, 1, no repeat, 2, no repeat, 3, no repeat. Therefore, it is a function. Now let's look at this visually, right? So if I took those same points and I graphed it, how can we just look at a graph and determine if that graph is going to be a function? And so what we're going to use is something called the vertical line test. And that is a set of points in the plane represents y as a function of x if and only if no 2 points lie on the same vertical line. So imagine you go through and you draw an infinite number of these vertical lines. If you can find one instance where it passes through 2 points, it's not a function. We would say it fails the vertical line test. So in this first one here, because it passes through 2 points, fails the vertical line test, therefore it's not a function. But if we look at the second one here, I can draw an infinite number of these vertical lines. It only passes through 1 point, so we're going to say that it passes the vertical line test. So let's use the vertical line test to determine if this is a function. Okay, well, if I draw a vertical line there, it fails, it passes through 2 points. If I draw an infinite number of vertical lines here, it passes, therefore it is a function. Now I know some of us try to think, we get a little cute here. We think to ourselves, well, what if I draw my vertical line here? Well, it passes. Why wouldn't it be then a function? And it's not if you can find a place where it passes, it's can you find a place where it fails? That's what we're looking for. If you can find an example where it fails, then it's not a function. What happens if I have a graph and I have a point? So in this instance, I have this point sticking out here and below it is a graph. Well, if you draw a vertical line there, it's going to fail the vertical line test, and therefore it's not going to be a function. But on the other side, because there's this open circle here, it actually means if you draw a vertical line in, it's only going to pass through this point here, but then it's not going to pass through a point there, so therefore it actually would end up being a function. For this one right here, it's not a function because it fails the vertical line test, and then no matter pretty much anywhere I draw these vertical lines here, it's going to fail the vertical line test, so it's not going to be a function. So what did we learn today? We learned how to determine if a relation is a function. Now, what is a function? It's basically a type of relation in which an x only maps to one y value. It cannot map to more than one y value. And how can I tell if a graph is a function? We're going to use the vertical line test. We need to make sure that if I draw an infinite number of these vertical lines, every single time it's only going to pass through one point. This does conclude our lesson. If you have any other questions, please leave them in the comments.